はい。というわけで、配信が始まったかと思います。第4回、AIST Creative HCI セミナーを始めていきたいと思います。よろしくお願いいたします。毎回のことではあるんですけれども、セミナーフォーマット、今回も、オンラインでやっておりまして、この Google Docs が、用意されております。こちらに、質疑の内容ですとか、気づいたこと、議事録的な使い方ですね、をしていただければと思ってまして、Google Docs が、こうなってて、こちらをみんなで使っていこうと思います。今回はですね、明日、6月24日土曜日に開催の改弁協会と、連動する形での開催となっておりますので、冒頭ちょっと日本語で喋っております。講演自体は、英語でお願いしてあります。最後のパネルディスカッションは日本語です。で、改弁協会もですね、現地参加、まだ受け付けていると思いますし、現地の参加が難しい場合でも、YouTube ライブで参加できますので、ぜひぜひ皆さんこちらもよろしくお願いします。でタイムテーブルなんですが、今、少し遅れて始めましたが、セミナーの紹介をしておりまして、この後原さんにお話しいただきます。それから荒川さん、中川さんに話していただいて、最後パネルという形です。今回のテーマなんですけれども、海外で研究することということになっております。ここからちょっと英語で喋っていきます。So, for this edition, we have the focus on walking abroad. And as you can see, all of these speakers have some sort of origins in Japan, but are currently studying in the UK or working in US or teaching in Singapore. So we kind of discussing what it is about, I mean, working and studying abroad throughout this invited talks and panels. This seminar is organized by AIST and co-organized by ACM Sikai Japan chapter, and is also supported by the advisory board as shown here. So from now on, I will switch to Dr. Kotaro Hara from School of Computing and Information Systems, Singapore Management University. Let me stop sharing the screen. So, Dr. Hara, are you ready?
Yes, try.
Great. So, please share the screen and start your talk. Thank you so much.
So thank you very much, Kato-san, for inviting me for this AIST talk. So yeah, he invited me and then he asked, hey, please talk about something that you do, something that the research that you do. So I was like, okay, I'm just gonna talk about everything I do. Yeah, my name is Kotaro Hara. I'm an assistant professor in Singapore Management University. And a little about myself. So yeah, as Kato-san introduced, I'm originally from Japan. I'm from Osaka. When I was in undergrad, I was studying in Osaka University. It's a university in Osaka. And then after I graduated my undergrad, I moved to the US. I went to this place called University of Maryland, College Park. And then I was doing postdoc in Carnegie Mellon University. And now I'm here in Singapore, in a place called Singapore Management University. So I'm doing assistant professor there. And I do HCI research. And as you all probably know, if you're doing HCI research, it's a humongous research domain and different people are doing totally different things. But I'm working on the subfield of accessibility. So just so you know, just so that we are on the same page, what is accessibility? So accessibility refers to the design that supports people with disability, like visual impairment, blindness, or hearing impairment, or motor disabilities, like wheelchair users. But in the context of computer science, it's all about creating or designing accessible softwares or hardware, or evaluating the accessibility of existing systems. And yeah, even within accessibility, there's a whole range of subdomains. Some people working with people with visual impairment, some people are working with people with developmental disabilities or mobility impairment. And yeah, but I tend to work with people with visual impairments, developmental disabilities, and motor impairments. And accessibility research in HCI, we tend to study the accessibility of systems like social technical systems, social media, or all these user interface technical devices like mobile devices. Then we also tend to create novel interaction methods to support accessibility. And today, what I want to do is use my own research as an example to kind of showcase, what accessibility researchers in HCI do. Okay. So how I got into this domain is, well, I started my PhD and my advisor dragged me into this domain. He wanted to do accessibility research, so I was like, okay, I'll do that. And then, yeah, I started this line of work around 2012. And when I was in PhD, I was mostly working with people with motor impairments, mobility impairments, like wheelchair users. And I'll talk more about it later. But then I graduated, I started my postdoc, I moved to Singapore, and I was very bored of doing the same line of work. I was kind of doing, this PhD work, like a little bit, I switched my research domain to something more related to work, like economic activities of people and something to do with accessibility and computing. Okay? And I briefly talk about that too. But yeah, first let me talk about briefly talk about my PhD work, more accessibility work related to mobility impairments. Well, just a context, in the world, like worldwide, there are about 65 million people with some kind of mobility impairments. And the mobility of these people, like how they navigate the city, they get disrupted because of problems like missing curb ramps, obstacles, surface problems, or just sidewalks are completely missing. And of course, these are not really computing problems. These are more infrastructural problems. But also, we argue that this is informational problem as well, because there are very few mechanisms right now to determine the accessibility of a city in advance. Right? So at the beginning of this research project, we talked to people who use wheelchairs or other assistive devices and basically asked, hey, what do you do when you're traveling the city? Like, what do you do when you go out? How do you plan your trip? How do you assess the accessibility of the destination that you're planning to go in advance before the trip? So we talked to them, we just engaged with them, and they said, oh, it's a problem. We don't know the accessibility of the cities, streets, and destinations. So it would be nice if we can have visualizations like this. So this is a heat map prototype. And if you're on wheelchair, you can click this area and see the accessibility for you. Like if it's red, say it shows, oh, this area of the city is not accessible. So you should be careful. Maybe you should go there with your caregivers. But green area is more accessible. So probably you can travel independently. And these people also mention things like, oh, I want a Google Map navigation system, but something that's more accessibility aware. So that was good. So they ideated and they told us, yeah, it would be nice if we have these kind of tools. But we thought, okay, if you want to create such a geographical tool, GIS technologies, then we need a lot of data about the city's accessibility. But we just don't have such data because it's very hard to collect it. So currently the common practice of collecting this kind of geographical data about accessibility is called walk audit. So volunteer organizations or government officers, they walk around and manually assess the accessibility of the city. And it's really tedious. And to mitigate this, some cities, they incorporate citizen participation. They create this kind of app so that people can report things like broken sidewalk, which mitigates the problem, but it doesn't really solve the problem because still people have to go there and then assess the accessibility of the city. So what we try to do is use the online imagery like Google Street View and satellite images to see whether we can use this as a source of the accessibility data. So as I'm playing right now, if you go to Google Street View, you can see the surface or sidewalk, and you can say, oh, there's a pole standing out, and it's not accessible for wheelchair users, right? So obviously, this is, you can see it, you can see accessibility problems, but these are not indexed. So we want to somehow collect this kind of information, extract this kind of information, so that we can geographically index it, and we can thus use it for the system that we build. What we did is we used crowdsourcing. We recruited volunteers or crowd workers and asked, hey, what kind of problems exist in this picture? And they said, okay, there are poles standing out in this picture, and there's a missing curb ramp at the end of the crosswalk. So that's what they did. And to ask people through this crowdsourcing approach, we created this user interface, the web user interface built with JavaScript. So you can look around this Street View world. You can zoom in, and you can say, oh, there's a missing curb ramp, so this is not accessible for wheelchair users. And this is really severe. And once you label it, this system uses this label and also the point cloud data that's given by Google Street View, and also the heading angle, like where the user is looking at, to estimate where on the map the problem exists. So it kind of reprojects these labels onto the top-down view. So using this interface, we collect a lot of data, and it gets mapped to the top-down view map. So we can collect a lot of information. And once we collect it, we can use it for making systems. But then the question was, okay, we create this system, but is the data that we collect accurate? So that's a more of an evaluation part that we did. And we used Amazon Mechanical Turk. We hired 185 people from Amazon Mechanical Turk. And I skipped all the details, but basically we found that the accuracy is okay. It's not like perfect, but we saw that 87% of accuracy, with 57% of accuracy, we can collect this kind of geographical data. So that was okay. So to qualitatively show what kind of data we collected, here you go. So these are the labels that people provided. So crowd workers saw this Street View picture, and then they marked, oh, there are curb ramps missing. Or in this picture, they could find this, but sometimes they made mistake. For example, people incorrectly label this object in path, but it is an object in path, but it's really not an obstacle because there's enough space for wheelchair users to pass this sidewalk. So we labeled this as incorrect. There's like a subtle difficulties in evaluation as well. But okay, anyway, 87%, it was not too bad. So we decided to deploy this system to public. So not only hire crowd workers, but also volunteers could participate. So we invited people people anywhere in the world to use this tool, deploy the tool, and label the sidewalk in Washington, D.C. We chose D.C. because it was right next to my university, University of Maryland, College Park. And we deployed it for 18 months. And we covered entire streets in DC. So we assessed the accessibility of every single street in Washington, DC, which amounts to 2,941 miles. And we collected like 200,000 labels about accessibility. So now we collected data, we could use this to say create visualization to show which area of the city is accessible and which path is accessible for wheelchair users. And we're kind of running out of time, so we quickly, but yeah, so that was crowdsourcing part, but it still required manual work, and it's probably okay to collect data for one city, but if you want to collect the data from every single city in the world, then probably it doesn't scale well enough. So we want to automate some part. So that's what we did. We tried to use computer vision algorithm and detect some accessibility features from Street View. And that's what we did. And we tried to detect curb ramps because that's really significant feature for wheelchair users navigation. And we thought it's easier to detect than other things like obstacles and paths, which was not really the case. But anyway, so back in the day, before the deep learning became like really popular, there was this object detection algorithm called deformal part model. So this is what we use. And basically, instead of detecting people or bicycles, we try to detect curb ramps. And this is we train the algorithm and we apply it to Street View picture, and this is the output that we get. And it detects something. It detects curb ramps, but we also find multiple redundant detection boxes. And also, we don't want curb ramps in the sky or on top of the roof. So we want to delete these things. So again, we use this point cloud data provided by Google Street View to detect the surface plane, and then we filtered out all the things that are not on the ground. We still had some errors, like these things. So we had another layer of machine learning algorithm which incorporates heuristics, like, okay, we don't want like labels that are really huge, and we could further refine this. So that's what we did. It kind of worked. It was not too bad, but when we compared it against human label accuracy, who could collect data with 80 to 90% accuracy, computer vision was not there yet. This was back in like 2014. So maybe if you try it now, it's slightly better. But at that time, it wasn't that great. So yeah, that's what we did. Okay, so that was my PhD work. So it was all about collecting geographical data about accessibility of the city. But then after doing this research for 5 years, I got really bored. So I got into slightly different topic. So when I was doing my PhD work, I was using crowdsourcing and I was working on accessibility. I was working on accessibility. So I got interested in these economic activities of people with disabilities. Like, how do they work? How do they make money? So that's what I started working on since my postdoc time, and I still try to work on this. So let me introduce some projects that I work on right now, or that I worked on a few years ago. So one project that I worked on, it was related to autism spectrum disorder, ASD. So kind of stereotypical definition of ASD is people have hard time communicating, socializing with other people. But these people, they also tend to have other comorbid characteristics. They have disabilities in cognitive functioning, learning, attention, and sensory processing, like hypersensory. Yeah, hypersensory. I don't have stats for Japan, Singapore, or other countries. But when I was in the US, I found these statistics. So about 3.5 million people in the US, they have ASD. It's more male dominant because it seems to be related to gene, like sex gene. So it's more male dominant. This number is increasing because the diagnostic criteria is evolving over time. So that's ASD. Another thing is, adults with ASD, they tend to be more unemployed because of a bunch of reasons. So as I said, they tend to have this interactional difficulties, like talking to others. And also they sometimes have cognitive functioning, hypersensitivity, and so on. So things happen, right? So communicating with a boss become a challenge, and you cannot work on cognitively taxing jobs. Or if it's too bright, too noisy, your sense become really taxed and then you cannot work there and so on. And it's kind of terrible because it's about independence. It's about self-esteem, and you have to live, right? You have to earn money, and if you lose a job, it's terrible. So that's the issue. But actually, it's not only about them. It's not only about their problem because as a society, we spend a lot of money to support them. So for medical fee and non-medical fee, like occupational support, society spends, for example, in the US, they spend like $461 billion per year. So that's a lot of money. And trying to support them with technology and reducing this cost has the economic impact. So, we are like, because I was working on crowdsourcing research before, I thought, okay, can this kind of online work, crowdsourcing, provide an alternative work opportunities for this kind of population? So crowdsourcing is like Mechanical Turk, but it could be something more complex, like something offered in Upwork. And we thought, okay, there could be pros and cons. Like there's nonverbal and asynchronous online communication. And also work environment, it's unbounded by anything. You can work from home with your caregiver, right? But at the same time, there's a lack of this traditional work structure. Like there's no boss trying to train you, or a lot of work. There's a lot of work in crowdsourcing platforms, so that could be very overwhelming. So what are the trade-offs? So what we did is we just invited people with ASD, and we asked to use crowdsourcing platform, specifically Amazon Mechanical Turk. And I want to show you one video of a person using Mechanical Turk.
What does the question say? Oh, is this a picture of a baby? Okay. Do you want to click yes?
Okay, I hope you could hear. I hope I shared the audio. So yeah, what happened is I asked this person with ASD to use this interface Mechanical Turk to perform this image classification task. It's a very common task on crowdsourcing platform. But when asked, he could not do this task. He was like, what is it? But then I asked, okay, is this a picture of baby? Then he said, yes. And then I asked, do you want to click yes? Then he could do it. So people with ASD, it's, the current understanding of autism, it says that, people with ASD, they have disabilities in executive functioning, for example, planning ability. So maybe that's causing them to do really complex tasks that requires planning of understanding what's in the picture, do this classification task, and then actually click the button and submit, right? So it's a lot of tasks. So we thought, okay, if we can simplify this user interface, we can reduce the complexity of the user interface, maybe they can work on these tasks. So we created this tool. What's on the left is the original interface, and what's in the center is what I created. So let me just play the video. So this user interface extracts the image from the original interface. So this task is the image transcription task. And as a user, you can just look at this user interface and picture pane and just type in what's in this picture. And then you just keep hitting enter, enter, enter to perform the task. So you don't have to navigate the interface. That part is done by user interface. Oh, yeah, and then once we complete the task, then that result gets sent back to the original interface and gets submitted. So again, I'll skip all the details, but it seemed to reduce the difficulty of the task, and our participants could perform the crowdsourcing task more easily using our interface. Okay, so that was the one research that I was working on in postdoc time. But these days, I don't do research. I let my PhD students do research. So I have this PhD student, Rosie. She works on video accessibility. She she tries to make audio descriptions for people with visual impairment. I think a few weeks ago, a few months ago, Amy Pavel from UT Austin, she came and she gave a talk about audio description. So it's really related to that line of research. So yeah, I hope I still have time, like 5 minutes. I'm just gonna finish quickly. Okay, so there are
no
a lot of,
worries, no worries. There's
okay,
time.
okay. I'm pretty sure you waste your time watching YouTube videos. I do. But yeah, there are a lot of online videos, but a lot of them remain inaccessible for blind people. And the large part, in large part, that's because there is a lack of audio description. And what is this audio description? So rather than me explaining, I'm just gonna show you 2 videos so that you know what audio description is. So this is a video without audio description.
If you listen real hard, you can hear the whale.
And this is the video with audio description.
If you listen real hard, you can hear the whale.
Their arms extended. Back in the Subaru, then a hike after dark.
Okay, so I hope you caught the difference. So audio description explains what's going on in this visual scene. It verbally explains what's going on so that even you cannot see it, you can get a sense of what's happening visually, right? So if you're blind, you can get a sense of, oh, okay, this guy is opening their arms and so on. But the issue is it costs a lot of money to make these audio descriptions. So big production companies like Netflix, Apple, they can make things accessible, but it's unlikely that casual YouTubers can make these videos accessible because it's a lot of additional money. So my student, she was asking, okay, can we design user interface that allows novice, like a more cheaper labor to produce high quality scene descriptions, audio descriptions. So that's what she did. So this work was published in ASCA. And instead of me explaining, I'm just gonna play video.
Hi, I'm Conan. I'm of higher video minute. Return a week for a minute video. We present VScene, a web-based authoring tool that taps into the larger pool of sighted non-experts to help them generate high-quality description via succinct visualization and comments from a reviewer. Using VScene, a novice author writes initial scene description in session 1. Then, a sighted or blind reviewer reads the scene description and comments on how to improve them. And finally, the author revises their scene description in session 2 based on the reviewer's comments. VScene interface consists of 2 main components, a video pane on the left and a 4-column table pane on the right. The video pane has a video player and also a succinct visualizations underneath the video player. And the table on the right consists of 4 columns, which are a scene start time, closed caption, scene description, and feedback columns. The author types scene description in scene description column, and the system generates the synthetic speech of the scene description that the author types in the scene description column. This is the original video without the audio description.
Web accessibility perspectives. Colors with good contrast.
And this is the video with the audio description generated using VScene.
Web accessibility perspectives. Colors with good contrast.
A road sign with a blue background appears. A girl is walking down the street.
In the feedback interface, the reviewer will evaluate the scene description from the authors. They type their comments in the feedback columns, and then the authors will be able to see this comment and revise their scene description accordingly. To test the efficacy of the system and the workflow, we recruited 60 novice participants.
Okay, I'll skip the evaluation part. I'll skip the evaluation part.
Hi.
Oops. Yeah, so as Rosie, so it was Rosie speaking in the video. So as Rosie explained, she created this collaborative user interface, more like a CSCW-ish work. So blind reviewer and sighted authors can collaborate using this interface, and they can together make good audio descriptions for blind people. So again, I'm going to skip a lot of results, but at high level, they could collaboratively make good audio descriptions with much cheaper cost compared to expert, like professional audio describers. Okay. And she worked on another project, which was published in this year's KAI 2023. And so this was a bit more automation. So collaborative work between blind people and sighted people were good. But we also wanted to improve the efficiency of work by sighted people. So that's what we tried to do. And the first thing we tried to do was, why don't we just automate everything? Recent, like last 2 or 3 years, there's a lot of development in automating the image description, audio, video description. So why don't we just throw the deep learning model and then try to let it describe what's going on in the video? So that's what we did. Like 2 years ago, we used this model called like MART. It's a deep learning based model, and try to describe everything in the video, which didn't really work. And also, apparently, these people from George Mason University, they tried a similar thing. They used automated model to describe videos. It produced something that was kind of nice, but they said it lacked key details and accuracy was not that great, right? So automation, it's great. It's probably continue to be greater, but it's not really there yet. So we wanted to combine this work by human and also automation. So we created this system which combines them. What happens? What we created is a kind of tool where the sighted person can go to this interface. They can create the initial version of the description. And then there's a computer vision algorithm running in the background, and it extracts all the information about the video. And it suggests, okay, don't you want to describe these things? And it also uses this NLP component that's running behind the scene to compare what the author described and what provided as a feedback. If they haven't mentioned something, they present some suggestions as gray boxes. I think I'm gonna skip more the details of the algorithm because you can read that in the paper. And yeah, okay, I'm just gonna skip. And also, I'm gonna skip a lot of evaluation. So if you have questions, please ask me in the Q&A. But yeah, so takeaway is automatic feedback was useful for improving the descriptiveness and other quality of audio descriptions. And it can improve audio descriptions objectiveness when human reviewers actually decrease the descriptiveness, objectiveness. Yeah, and of course, it's more time efficient than hiring multiple people at the same time. Right. So yeah, sorry, I think I went a bit over time, but that was things accessibility research project that I worked on. So I hope you got a sense of what kind of things accessibility researchers in KAI community do. So we do make a lot of systems, but we also talk to people and try to understand what are the problems, what are the issues around technologies. Yeah, so that's it. Thank you.
Thank you so much, Kotaro-san. It was really great to see the work that you have continuously worked in this condensed format. It was really great. Yeah. So let's see. Yeah, I think we have some time for the question. And there are several questions. The first one is about your PhD work. And
Yes.
so longitudinal study, like you said, you mentioned that the study took 18 months, right? And
Yep.
for PhD students, they sometimes have a kind of, feel the pressure to publish papers quickly, and 18 months is already, great, like over a year. And how was it possible? And what was the motivation, or how did it work? That was the question.
Well, my advisor forced me to. But actually, so that was toward the end of my PhD. So I deployed it, and then I started collecting data. And I think like 12 months or something, I graduated, and another student took over. So yeah, she finished the work. Like she finished the work, did more data analysis. So yeah, that's a great point. So 18 months is very long for PhD students or anyone, I guess. So yeah, if you have multiple people working on that, then that helps. But otherwise a bit tricky. So it requires multiple people.
I see. Yeah, it's really great that the lab, for example, your lab has that kind of culture to kind of make the real impact by collaborations between multiple people. Last question, I think. So these days we see many HCI work tackling ethical issues or societal issues, and your work seems aligned with such trends. Not only your PhD work, but also the post-PhD work. Would you have any comments on this kind of trends or the role of HCI researchers in society?
So yeah, I think that observation is true. Like not only accessibility, I think HCI, a lot of people work on environment issues and also social equity. I think that's great. Like if you are into it, they should work on it. But yeah, I think it's great. But I think that there are other great work that's not really anything to do with like ethical issues or environmental issues or accessibility, right? Like I see a lot of great, like really technical work that's super impactful. So yeah, I think if something that's what people want to work on, then they should do it. Like that, there's a value in it. But I don't know. I think they don't have to. Like I see a lot of witty people or computational people who's doing something totally unrelated to accessibility or the social issues.
Yeah, that totally makes sense to me. Like we are kind of community of people with diverse motivations, diverse kinds of motivations. So yeah, thank you for the comments. Okay, so the next speaker is Riku Arakawa, who is a PhD student at HCII at Carnegie Mellon University. So Arakawa-san, could you start sharing the screen? Yeah, I can see the screen right now. Thank you.
Thanks. Thanks, Dr. Kato, for introduction. Hello, everyone. My name is Riku Arakawa, and I'm very happy to give a talk here today. So a little bit about me. I did my undergrad and master's at the University of Tokyo, and currently I'm almost finishing my second year at CMU HCII, Human-Computer Interaction Institute, and I came to the US 2 years ago. So my research is very roughly to say it's about applied machine learning with a strong focus in healthcare and human-to-human communication. And to achieve that, I leverage techniques from sensing or user digitization, and also some design strategy based on behavior change. Acknowledgement is my research is supported by FNAI Overseas Foundation, Masterson Foundation, SNAP Research, and Center for Machine Learning and Health at CMU. Okay, so today I want to spend the first half in talking about CMU HCII. I guess it's one of the most renowned institute for HCI. So I'm happy to share the information about that. And then I want to talk about my kind of research there. Okay, let's cut to the chase. So HCII stands for Human Computer Interaction Institute. And it's, I guess, probably, like CMU is kind of famous for its computer science. But when we say computer science, it's actually very broad in CMU. So under a big umbrella of School of Computer Science, there are 7 departments. The first one is a computational biology department, then computer science department, human computer interaction institute, language technologies institute, machine learning department, robotics institute, and software and societal systems department. And HCII is one of them, and it offered its first course in 1993. And according to the current web page, I counted, there are roughly 47 faculty members, and there are also approximately 70 PhD students. So what it means is it's pretty big, and it covers broad spectrum of HCI research. So to talk about more about this aspect, like why it covers such a broad spectrum of HCI research, I want to talk about the PhD program at CMU HCII. So when I joined CMU HCII 2 years ago, there are almost 20 other PhD students in my cohort the same year. And the first class we needed to take is called Practice and Theory of HCI. So it's a mandatory course, full semester, and we took this course as the same cohort. And there we learned how to, it covers a very kind of basic about becoming an HCI researcher. So we started with how to write a proposal to get funding, and then how to do literature review, and how to make a research question, how to conduct user study. And what was very unique and interesting to me was how we also learned like how to spend time during a conference. I guess if you ever attended a conference, you probably have faced a situation like you kind of don't know what to do next. And attending conferences with technically challenging. So it was great to learn some tips from advisors in the very beginning of our PhD career. So after that, as a requirement for graduation, we need to finish 6 full semester courses based on 4-1-1 strategy. So what's 4-1-1 strategy? So as I have already talked about, HCI is a very broad discipline, and people like me are like doing technical research, for example, developing new systems. But other people are doing different kinds of HCI research, like design or social science. So at HCII, they roughly classify these diverse topics into 3 categories: computer science, behavioral science, and design. And each student can select one of them as their major. So in my case, I choose computer science as my major because I'm a kind of technical researcher. So I need to take 4 computer science courses, and I need to 1 each from the behavioral science and design. And for each subcategory, there are many courses that are offered by the faculty members. So it's pretty flexible to choose whatever you want. So yeah, it's about the full semester courses. But in addition to these 6 courses, especially for the first and second year students, they need to take 4 half semester mini courses. So these are all mandatory, and these courses are offered to kind of enable students to know basics and history of sub-area of HCI. So there are 4 courses: computer science, behavioral science, cognitive science, and design. So for example, in computer science, I learned how the user interface has evolved and what kind of discussions have been happening. So it's really useful to know a broad kind of area about HCI, especially for me. Like I didn't know much about like behavioral science or design. So and also in these courses, the contents are basically discussion between kind of peer students, and some students have expertise in domains like I don't know. So it's really good to not only to like make friends, but also to kind of gain their perspective, and eventually leverage that for my own research. Okay, I have talked pretty much about courses. So lastly, I want to quickly mention about communication talk. So this is also a very unique point about CMU HCII, but we don't have an official qualification exam. So that means there's no transition from PhD student to PhD candidate. We remain PhD students until graduation. But instead, around the end of first year and second year, we need to give a presentation in front of all faculty members. Remember, there are like almost 50 professors, and we need to make a presentation and talk about our research in front of them. So yeah, this is a big deal. So we spend a significant amount of time in the preparation, but it's worth doing. We gain a lot of feedback from professors from different backgrounds, and also we get to know what other students are working on. So it's a very good kind of milestone that's placed around the end of each year. Okay, so these are sort of like excerpts from the handbook of CMU HCII. If you're interested, please refer to the link below. There are more details about how the program is tailored at HCII. Okay, so I have spent 2 years in CMU HCII, and I want to talk about kind of strengths I feel about the institute. The first one I've already talked about, but it offers very well-designed program to learn diverse topics in HCI. This is especially beneficial for people like me who have like a broad interest in HCI topics. The second part is community is big, and thus it's they kind of design it such that it can be supportive and having like warm atmosphere. So there are like frequent social events and get to know each other pretty easy. So I like the kind of atmosphere of the community. And also CMU HCII has a strong network in the HCI field. So most of the alumni, like our alumni, are playing key roles in the field of HCI. So we can easily reach out to them. And it's especially easy to get connections at conferences. And also there are good opportunities for internship or collaboration with others. So last but not least, I'll say Pittsburgh. So CMU is located in Pittsburgh in the east side of the US. Pittsburgh is a nice city to focus on research, I'll say. So I'm originally from Tokyo, and I'll say Pittsburgh has less distraction compared to Tokyo, and I think I'm spending more time in research compared to when I was in Tokyo. And if you think like 5 years, also Pittsburgh is very relatively safe in the US. So if you think you want kind of compact and quiet space, I think Pittsburgh is a good town. Yep. Okay. So this is kind of my last message, but yeah, it's pretty fun to be in the community. And I think for doing a PhD, PhD has inevitably both ups and downs. So it's good to have friends who you can go together with during the journey. So I'd like to encourage more kind of Japanese students to join this community. And yeah, please feel free to reach out to me. Yep. So this is about this is about CMU HCI. So in the rest of the time, I'll talk about my research. Oh, excuse me, Dr. Kato. So is it until like 35 or 40?
Well, it's sorry, I'm also not aware of that. It should be until 35. So you still have 10 minutes to go.
Okay, gotcha. Thanks.
Thank you.
Okay, so at CMU, I'm belonging to Smart Sensing for Humans lab. We call it SMASH lab, which is directed by Dr. Maya Goel. Roughly to say, I'm utilizing ubiquitous devices like smartwatch or smartphone, or even like wearable glasses, and use the data, apply machine learning to get information about users, and such as pose estimation and applying like activity recognition, or even like estimating their mental state. And based on these digitized data, I developed applications to help users and to make a kind of impactful applications. And I'm working in two fields, healthcare and human-to-human communication. And in healthcare, for example, I developed systems to support diagnosis or clinicians' decision-making, or even systems that encourage that kind of adapt intervention to guide users in a better direction. I want to show you some visuals to provide a better sense. So the first project I want to talk about is IMU Poser, which appeared in this year's KAI. So hopefully someone can cover this in the KAI Benkyokai tomorrow. Anyway, so this is led by this guy, Bimal Mani, who is an also incoming student, PhD student to CMU HCI. What we did was to utilize wearable devices such as smartwatch or smartphone to reconstruct our 3D body pose in real time. So, but in daily life, the configuration of each device, like what kind of devices we are wearing, can change, right? Sometimes we take off our watch, or sometimes we wear earphones. So we can train the model to adapt to those different configurations and successfully reconstruct 3D human body pose in real time. So this is kind of illustrating my research on human user digitization using sensors to get some user information. So next project I want to talk about is basically about how we can make use of those digitized data. So this project is about hyperactivity detection with smartwatch. ADHD affects approximately 5% of children and adolescents. And especially for school-age children, the ADHD has kind of different types. And the most dominant one is hyperactivity. Now, children move a lot. The current diagnosis for hyperactivity is pretty subjective. So there's a big need to add some objectivity to the diagnosis and measurement of hyperactivity. So we leveraged smartwatch for this purpose. So this visualization is motion sensor acceleration, specifically plot. The first row is a control child, which means the child without hyperactivity. The second row is a child with hyperactivity. And each column corresponds to different activities. For example, the first one is sleeping. So in sleeping, since children don't move, the values are almost zero. And the second column is doing like everyday household. So, for example, when you look at exercise column, both control and hyperactive children show a similar amount of movement. This makes sense because in exercise, they move a lot, regardless of their condition regarding hyperactivity. However, what's unique here is when you look at the sitting quiet, the control child doesn't show much movement because they are in sitting quiet condition. But for hyperactive children, even though they are in sitting quiet situation, they move a lot. So this was our first insight to make a machine learning model to be context aware. So we can leverage context as a filter for the motion data, and then build a classifier for hyperactive detection. I'll skip the detailed implementation, but we could successfully detect hyperactive children with reasonably high accuracy, like 90%, almost 90%. And then we are currently working on developing an interface to support clinician decision-making. So here, the human-AI interaction perspective comes in. So we are making interface based on machine learning model, and machine learning model has, various problems, like it has errors, and also it gets some bias sometimes. So how to make our interface interpretable and transparent is our question. So we're currently working on clinicians in the local hospital and then refining the interface. So yeah, please look forward to more news from me. Okay, so time. Okay, I think I can.
Yeah, you can go on.
Oh yeah, thanks. Quickly go. This is the last one. So another task I'm working on, and another project I'm working on is a procedure help navigate users go through procedure task. The procedure means a collection of steps with some order constraints. So like cooking, for example, or crafting something, or even a COVID-19 test kit is a procedure. You need to follow some steps. But sometimes we forget, like we miss one step during the procedure, which mess up the procedure outcome, or we forget what to do next. So our goal here is to develop an intelligent agent to navigate users through procedure tasks. So yeah, again, we leverage smartwatch. We thought that I think the most simple, kind of the simplest way is to use camera and apply computer vision technique to get context. But camera also has some problems like privacy. So we believe in the power of smartwatch to support users, thanks to its kind of ubiquity. Yeah, we can successfully develop some pipeline, and so our main application focus right now is in the healthcare domain. So we are collaborating with a hospital, and there what we focus on is a self-care procedure after Mohs surgery. So this surgery is basically a surgery against like skin cancer. And after the surgery, the patient gets wound on the skin. So we want to support patients to do self-care, like after they got surgery and they get to back home, they need to do self-care every day. So we want to support that procedure with smartwatch. Okay, wrap up. So research from now on, I want to focus on deployment of these systems like ADHD detection or self-care support system and evaluate them in the wild. And eventually my research question is to explore like how we deploy AIs to real-world situations with a high need, and also how we design AIs that deal with highly human context, which I didn't talk about during this presentation, but if you're interested, please visit my website or feel free to reach out to me. Okay, I'm happy to take questions, but before that, I put some links where I provide more information about my research, as well as some PhD student life. So and I'm currently writing an article about CMU HCII, and which will be published in the September issue of Jun Kato no Gakkaishi in Japanese. So also please refer to that if you're interested. Thanks for listening.
Thank you so much, Arakawa-san, for the great introduction of CMU HCII, as well as the introduction to your own work, which is really a great application of machine learning techniques. I think we do have some questions, but I think, let's see. I think we can answer to these questions in the panel discussion, I guess. Shall we move on to Nakagawa-san's presentation? Is it possible? So right now, I'm switching from Arakawa-san's talk to Nakagawa-san's talk. Nakagawa-san, are you ready?
Yes.
Great. Let me stop sharing the screen and you can start sharing the screen. While Kotaro and Riku are both post-PhD life or at the later stage of the PhD, Nakagawa-san is currently an undergrad student at the University of Bristol. So I think her presentation would be a little bit different in style, I guess, but I'm pretty sure it's really great presentation. So please go ahead, Nakagawa-san.
Okay. So firstly, thank you for inviting me and introduction, Jun Kato-san. And I'm very honored to be speaking at this session. Well, I'm still a bachelor student, so please go easy on me. So hi, my name is Manami Nakagawa, and I'm studying computer science at University of Bristol. And I'm still, I still master students. And wait, this slide doesn't work. Okay. So who am I? In short, maybe introducing current position would be helpful. So I'm working on a human-computer interaction project as intern at a Japanese company called Omron Scientifics. And at the same time, I'm also participating in Google STEP, which is a software engineering training program. And now currently I've been on a leave of absence from University of Bristol, but will be in the final year of my third year in September. And who am I? My post is too messy. So and also there are only a limited number of projects I can mention. So, but I will introduce as many as I can on a project basis. And for the last 5 years, I've been moving between countries because of the COVID pandemic and changing where I live more than 10 times. And there's so much I'm doing. So it took me a while to sort it out. But if you look at my background with my passion for human-computer interaction, there's a relatively straightforward story. And which is that I got interested in human-computer interaction and tried to study human-computer interaction in Bristol and tried to gain skills for that. And finally got the human-computer interaction project at Omron Scientifics. So in this session, I'm going to talk about why I got interested in human-computer interaction and why I chose Bristol and how was the life in the UK and also the project I've done. So firstly, how I got interested in HCI. So my first project was based on the classroom in our high school. So in our high school, because they like ICT, we all have the iPads. So teachers did. I know it's kind of rich, but yes, anyway. However, the paper was easier to understand for the elderly teacher, and the also like people are suddenly given the iPad. So even like high school students, they can't use well. But when I saw the school full of papers, even though all the teachers and students had iPad, I saw must be something I can do for this. But at the time, I didn't even understand what is the difference between coding, programming, and hacking. I only know them from TV drama. So I attended a program that teaches programming to like middle or high school students for 5 days in spring breaks. And at the program, my mentor brings his friends, and the friend recommended me Mito Junior. It is a program, and I'm very thankful for him to change my path. And quickly, what Mito Junior is, so it is a junior version of Mito organization, and it is selected on a project basis where mentors provide technical and financial support for 6 months. So after our project was selected by Mito Junior, I was trying to create an application to facilitate and to smooth the communication between the teacher and students. But still, I didn't have enough coding skill at the time. So I was looking for something more that I could contribute. And at the time, I worked hard on a school activity, and I had to get over 300 people, around 360 people to dance at sports day at the Kyocera Dome. So I had a network in school. So I decided to do user study in the cafeteria. And I brought a prototype there and talked to random people and did user studies. But still, I didn't even know the term, what the user study is. I just wanted to find out from users that we could improve on the prototype. So this is the beginning of my how I got interested in human-computer interaction. But in this context, maybe some people are gonna think my interest is about a UI, not HCI. But I was frustrated at the time is if there's a design of the pairs that user interact is not well organized, the function or technology itself will not be appreciated. And also at the time I was doing astrophysics research by myself at this organization, and in which I wanted to bring latest technology, the super kamiokande for observing neutrinos to education scene. So then I realized that I seem to applying the latest technology to every life. So that's why I got interested in human-computer interaction. And while try to study computer science or human-computer interaction in university, I was told that I can go overseas university after I graduated my high school. So it was too late to apply. And I started thinking about to going study abroad. And US community college or a foundation year in Australia is also the option. but because I like British accent and also some financial situation, I decided to work for the university in the UK. And why Bristol is, by the way, Bristol is located here. Many people ask me, where is Bristol? What is Bristol? So Bristol is located here. And when I searched the universities in the UK, so I saw the information, Bristol University has Bristol Interaction Group. And also, unlike the US and Japan, like UK university have a lot of compulsory subject or units and not so many optional ones. But the only optional one is like at the final year. And then I could find human-computer interaction unit in the catalog. So I decided to go to Bristol. And I got a conditional offer there. And I went to the foundation year process, which is a pre-university process. So I'm here now. And I went to the London, but the lockdown happens immediately after I went to the London. So this is the London I knew at the time. So the bottom left tube picture is previous, like probably from the eve of the lockdown. Like at the time, international students, including me, were watching like text information on Twitter, not TV. So we don't know like how serious and how exactly the lockdown starts. So we tried to go to the Ippudo in London, the famous Japanese ramen chain store, but it was closed, even McDonald's. So we decided to go back to our home, but the tube was like completely empty there. And the following morning, I got an alert from the government on the message. And I think these pictures are after like 2 months, like when we could walk around. So I could see any like message or graffitis about COVID there. And also the cities are all closed. But as positive side, I could see the Kai 2020 online, thankfully. So yeah, don't see that any like table product is messy, but I could still like keep my motivation for human computer interaction. And this is when I was taking online courses on data science from the University of Tokyo, Matsuo Labo. I will later introduce because I interned there. And at the time, because of time difference, it's 3 a.m. So outside is dark, but my electricity in my room was completely broken. So I just tried to study with like bathroom lights at 3 a.m. So it's like Keisetsu I guess. This is the cookie, my favorite. I gained 10 kilos because of this cookie. But after I progressed to the university, at the first year, I was an informational educational teacher, daytime, and I take a lecture at night. So it was very tough. So I lost 15 kilos. So yeah, it's from I lost 5 kilos after my journey in London. Anyway, and when I went to the second year, finally my university life starts. So the Bristol University is here. Lots of hills here, and like I thought I have a heart attack almost for the first time I climbed to the university, but I'm not getting used to it. And this is from the picture. This is picture from the laboratory, like a lecture during the coursework period. So my TAs and the lecturer helped me to debug the coding. So I'm physically here, but my mentor is here. This is from my like Instagram story. So, and this is just for proof I have a friend in Bristol. This is formal dinner, like at Christmas season. UK University often have this kind of thing. Oh, and the time is now getting over, so I quickly introduce. So I was doing the, I'm not familiar with university, but I think many of my UK university getting project from governments. Then one of the project I was working on was the Wales government planning inspectoration. So the facility is used for planning new buildings, checking for any problem in surrounding area due to the nature and due to the surrounding area. And due to the nature of the inspectoration institution, the communication was main problem. So we developed an application to automate contact management. So that was first time for multinational hybrid team development. So that was very tough. And and after that, I worked on the participate in Mercari's training program. And I won the best prize at the hackathon there. And what I did is, so the topic of hackathon was a new feature of the application, Mercari. So Mercari is an application for free market, a platform for customers to exchange secondhand and organization goods with each other. So we focus on the fact that the condition of the goods on display is judged subjectively by the user, like good or bad or very good. And we thought that if we could use image processing to score the damage condition of the product, it would be like a lead to peace of mind when exchange goods. And it would have been more interested to find out how the actual scoring would affect user like emotion. And after the hackathon, I go back to Japan to do internship. So internship, there's a limit I can say, but here I'm mainly developing my data science or ML skill here. What I did is roughly with analyzing data to propose and validate new features. So as for Mercari, I wrote tech blog in both English and Japanese. So if you're interested, have a look. And as mentioned, I'm now involving in human-computer interaction project at OMO, but it's the other one. I will present my personal development. It's not related to the my organizations. So I developed a web application which can do mock interviews. So after choose language setting, you can set the scenario, including pressure level.
Hello, Hannah. Thank you for joining me today. How are you doing?
Hi, nice to meet you. I'm good, thank you. How are you?
I'm doing well. Thank you for asking. Shall we begin the interview?
So there is a lag in Avatar's response, but you can enjoy the tension that Avatar facial expression as recording starts immediately, and feedback and scores returned at the end. And I deployed this application open. So if you're interested, please go to the product handle here and enjoy it. And I'm trying to investigate the way to develop further. And I'm also interested in like how it's gonna be affect if avatars actually interview the users, because it would be very tough for me if the avatar reject me, even human decided if like candidates is taken or not. So yeah, if you're interested, please contact me. And that's the quickly introduce of my project and my journey. Thank you for listening. And also if any suggestion for my master degree or PhD degree, or conversely, if there's anything I can do, please free to contact me here. So thank you for listening today.
Thank you so much. Thank you so much for the great talk and also your various kinds of experiences. I mean, not always good, but sometimes it might be tough, but it's really great to hear all of that. Well, we have some questions. One is, I think, relatively easy to answer, so let me just touch on that. I think this is about the last one, the interview system. How do you calculate the score in the interview practice? What is the calculation metrics?
So for the calculation, we also as you may know, as you may like realize, it's used GPT API. So for even the calculate the scores, we ask GPT to calculate, but we have a certain prompt that our like criteria for that. And yeah, so it's language models scoring.
I see. Sounds like pretty much like a modern way of making applications. Thank you. So, okay, let me share the screen again. So right now, the third invited talk is finished, and we're moving on to the panel discussion. So Hara-san, Arakawa-san, could you turn the camera on? Okay, great. I think we can switch to Japanese from now, I guess. すいません、ちょっと日本語でじゃあ、ここからは行きたいと思うんですけれども、皆さん本当に、まずはありがとうございました。どのトークも素晴らしく、こう面白かったですし、陰に陽にやっぱりこの海外で勉強するとか研究するっていうのはどういうことかっていうのと関係しているトークだったかなと思ったんですけれども、で、ここから先は特に台本がないのですが、皆さんなんか、他の方の話を聞いてちょっと触れたいこと、思ったこととかありますか？最初にもうそこから喋っちゃってもいいと思うんですけど。原さん何かありますか？すいませんね、ちょっと順番に、はい、聞こうかと思って。突然の振りを。
僕はちょっと気になるのは、トーク中にも話していただいたんですけど、荒川さんと中川さんが、そもそもなんで海外に行こうと思ったのかというのを、もうちょっと詳しく知りたいなっていうのと、あと、どういうふうにして、今いるところ、ブリストルなり、CMU なりっていうのを、ここに行こうと決めたのかっていうのをちょっと知りたいなと思いました。
ぜひお答えいただけますでしょうか。荒川さんからじゃあお願いできますか。
わかりました。そうですね。多分 HCI に興味持ったのは学部の終わりくらいから。で、そこもともとものづくりが好きだったので、ものづくり続けたいなと思ってて、それで何かしら研究ができたらいいなっていうところで、HCI に興味持ち始めました。で、東大の修士で研究しているときに、やっぱりその、リテレチャーレビューというか、論文をサーベイするとかがあるってやると思うんですけど、その時にすごい、なんかめっちゃ特定のラボから出てるな、みたいな。もちろん今思えばその他って他のラボが出てるんですけど、なんかやけに目につくラボとかがあって、見るとCMU とかあったりしたので、で、CMU ってすごいんだなと思ってました。で、最終的に そうですね、PhD やりたいなと思って、日本の環境も良かったんですけど、なんか20代で海外に出てみたいなって思いがあったので、海外のところをアプライして、で、嬉しいことに合格もらえたので、選んだって感じですね。はい。なんか、詳細とかは、もっと詳細、僕の奨学金の財団のホームページとかになんか前、こういう経緯があってみたいな詳細の書いたので、もし興味があったらそっちも見てみてください。
中川さんいかがですか？
そうですね。私が海外に行きたいと思った詳細は、大学進学、高校3年生の時に、私は一回国内大学しか考えていなかったんですけど、家の財政状況もあって、ただ、普通の学校、インターナショナルスクールとかじゃなくて、普通の学校なんですけども、なんか、水戸ジュニアのチームメイト、同じクラスメイトの2人が、2人とも海外大受験をしていて、で、自分って英語喋れないだけで、こんなに自分の選択肢ですらこんなに狭めてたんだって思ってしまって、だったらこれからなんか自分ごとじゃない選択肢もきっと幅を狭めてしまうだろうなと思って、英語で HCI を学べたらいいなと思って見始めたっていうのが海外に行きたいと思ったきっかけですね。で、なんでブリストルかっていうのは、結構省いたところもあるんですけど、それこそ CMU とか、すごいなんか HCI ユニバーシティで調べたらいっぱいいいところ出てきたんですけど、アメリカの大学に行くには、ちょっともうアプライが遅すぎて、UK のトップスクールとかには遅すぎて、で、エッセイの対策にも時間とお金がかかるっていう状況で、コミュニティカレッジもなんか UC 圏に住むにはお金が高いし、行ける保証もないので、じゃあ UK のファンデーションをちゃんと卒業できたら行けるようなところに行こうっていうところで選べるところの中からヒューマンコンピューターインタラクションって調べて一番ベストフィットだなと思ったのがブリストルなので、そこに選びました。
ありがとうございます。なんか原さん追加で何かありますか？大丈夫ですか？
いや、大丈夫です。特にないです。
いや、なんか、すごいなと思って。
順です。
やっぱりなんか、お二人の話聞くとすごいエンカレッジングだなと思うんですよね。なんだろうな。いや、その帰国子女とかの人もいますけど、こう、ね、ある意味、純ジャパと言われるような、日本で育っていて、特に中川さんとか英語も、だから多分そこから勉強されたっていうか、どういうふうに上手くなっていったんですかね。さっきの聞いてても全然普通に意思疎通できてますし、なんか、どうやって英語が身についたのかちょっと気になりました。
そもそも前提として私はまだまだだと思っていて、英語を人前で喋るのをなるべく避けているレベルなんですけども、どうでしょうね。高校の授業も海外大進学するなんて思っていなかったので、全部英語の授業は寝ていて、高校の先生に海外大行くって言った時に、本当に行くのかって言われたぐらい、あんまり文法的には正しくなくて、どうやってうまくなった？そう、多分、行きの電車で、学校に行くまでの行きの電車で、単語帳を見るのも疲れていて、ひたすら聞いていたんですね。聞きながら寝ていたんですね。なので、それが多分、リスニング力とか、ちょっと発音にはいい影響が出たのかなと思うんですけども。でもまだまだ文法とか、紙のペーパーテストとかでは結構ボロが出てしまうので、精進中です。
確かに喋るのとね、書いたり読んだりするのまたちょっと別ですよね。で、こう、シャドーイングとか言いますけど、こう、やっぱり耳で聞いたのそのまま喋ってるだけでも結構上手くな、喋れるようになったりもしますし、そういうのはあるんでしょうね。そっか。多分中川さんだけ、ある意味ヨーロッパで、荒川さんと原さんはアメリカですよね。原さんアメリカからシンガポールですけど、なんだろうな、なんか海外って言った時にこう結構ひとまとめにされがちですけど、割とカルチャー違うような印象が個人的にはあって、その辺ってこう、なんか印象あったし、荒川さんに聞いてみようかな。なんか。
アメリカの博士だと一番違うと思うのかな。長さが長い。博士課程5年間があるっていうのは長いところだなと思ってて、日本でも3年 多分イギリスは3年とかなのかな。一般的だと思うんですけど。で、長いことって多分、良い面も悪い面もあって、人それぞれだと思うんですよね。人のそれぞれの状況で、早く博士取りって、仕事を取りたいっていう人とか、ちょっと5年は長いなと思いますし、多分日本人から来るときとかって修士を経てから来るので、あれですけど、逆に5年間あると、僕とか修士からやってきてるんで、教授とかになると忙しくなっちゃうんで、その前に自分の研究に使える時間がめっちゃ5年もあるみたいな考え方がなってて、そこら辺は5年のシステムに助かってるなと思いました。
確かに。長尾さんのケースだと、今、学部生ですけど、そういえばこの後って、あれなんですかね、HCI のどこかのドクターに行かれたりするつもりなんですか？どういう希望を持ってらっしゃるのかなって。聞いていいのかちょっとわかんないです。決まってなければ。
学校は決まってないんですけども、もうちょっと勉強したいっていうのはあって、その PhD まで行くかはちょっと考えては若干いるんですけども、マスターは絶対行きたいなと思っていて、で、本当におすすめが聞きたいというレベルなんですけども、ちょっとブリストルからは出ようかなっていうのは結構心が決まっている状況で、他の大学を受験するにあたって、そのアメリカの HCI が強いところを行くか、ちょっとお金もちょっと若干怪しいので、っていうのもありますし、日本でちょっとインターンして、日本も結構 HCI 強いなっていうのはすごい実感したので、日本に戻ってきてもいいなっていうふうになっていて、すごく今考え中といったところです。
ありがとうございます。すごい国際情勢を反映したコメントだったなって今ちょっと思って聞いてました。確かにね。いや、ヨーロッパとかだと、割と日本と近い、修士博士、修士の後に博士が来るみたいなシステムを取ってたりするところも多いですよね。シンガポールってどうなんですか、その辺は。修士博士。
修士博士、ちょっと違うかなっていうのが、アメリカとも日本とも結構違うかなと、5年くらい住んで思ったのが、マスターっていうのが、リサーチっていうよりもプロフェッショナル思考というか、どちらかというと MBA みたいな感じで、キャリアチェンジのためにマスターを取りに行く。本当に勉強して、キャリアチェンジとかキャリアアップのために行くっていう感じなんで、それがちょっと違うかなと思います。日本だと、もちろんそういうのはあるんですけど、修士って言ったら、特に理系だったら、研究とか勉強するために行くのかなっていう感じだと思うんですけど、アメリカはそうですね。アメリカは結構ミックスですよね。本当にがっつり勉強してリサーチ方向に行くための、マスターとかもありますけど、どちらかというと、プロフェッショナル思考の、データサイエンスの、キャリアに行くために、そういう感じのプログラムを取りますっていうのがあるんで、アメリカは結構ミックスだなって思ったんですけど、シンガポールはもっと極端に、マスターはどちらかというとプロフェッショナル。で、研究やりたかったら PhD みたいな感じですかね。で、どちらかというとマスターの方が人気があんまりリサーチは人気がないのかなっていう感じがします。特にローカルの人にはあんまり人気がない気がします。
博士課程が人気あるないともしかしたら関係があるかもしれない。ポジションがどれぐらいあるかっていうのも結構影響しますよね。
そうですよね。出口的に、出口でも入り口でも、ちょっと違うのかなっていう感じです。出口的にリサーチのポジションっていうのが、そもそもシンガポールっていっぱいんで、シンガポールにいたかったら、そんなにポジションがないのかなっていうのもあるし、あと、シンガポール、なかなかエコノミーの調子がいいんで、そんな博士とか取らなくても、そこそこいい職に、すっと入れるというか、面白そうな職が取れるんで、結構みんなアンダーグラッドを卒業したら、すっと就職してしまったり、で、マスター取っても、さっき言ったみたいに結構キャリアチェンジみたいな、思考が強いんで、そうですね、PhD プラスに、もう、企業でずっと働くみたいな人が多い気がしますね。で、リサーチ、 荒川さんも言ってましたけど、やっぱり長いんで、5年も、シンガポール、PhD はお金は出るんですけど、言うて、生活費プラスアルファみたいな感じで、もちろん企業に就職したらもっともらえるんで、なんで5年もそんな、なんで5年もそんな時間を使って、そんなことしないといけないんだっていうのも、感じてる人もいるみたいなんで、そんなに、人気は、高くないのかな。
なんか日本だと、日本の博士課程に行って、その間に、海外の研究インターンに行くみたいなルートが、前はあったんですね。コロナでちょっと文化的に、最近難しかったですけど、僕なんかまさにそれで、博士課程は、東京大学だったんですけど、その間になんか3回ぐらい海外に研究インターン行けてて、なんか、それは割と個人的にはいいところだったなっていうか、日本の美味しいご飯食べながら、時々出稼ぎに行くじゃないですけど、なんか海外の文化に触れられたんで、あれはすごいいい経験だったなと思うんです。だからシンガポールって、そういう博士の間、インターン行ったりとかってあるんですかね？
ありますね。むしろめっちゃ奨励してるというか、今も僕の PhD の学生が、ミシガンにインターンシップ行ってて、企業でもよかったんですけど、ミシガンのそのアクセシビリティとかテクニカルなことやってる、先生のところに先月から行ってるんで、トータル多分3ヶ月くらい感じですね。で、みんな、大体1回は行く感じで、多い人だったら2回くらい、インターンシップに行ってるみたいですね。やっぱり、お金出稼ぎって言いましたけど、結構、それも大きかったのかなっていうのはあるんですけど、やっぱりなんかなんというか、ずっと同じところで同じ人と研究をしてると、飽きるというか、研究の、なんかレパートリーも増えないんで、僕も出てけみたいな感じで、どっか行ってこいみたいな感じで送り出したりしますし、他の先生も多分そう思う。
やっぱキャリアの初期になんかいろんなスタイルを、楽しむというか苦しむというか、経験するのは、なんか結構大事な感じはするんですよね。荒川さんの場合、そもそも CMU の HCII でさっき4対1対1っていうストラテジーがあるっていう話されてて、あれもなんかある意味いろんなスタイルを知るっていうか、いろんなエクスパティを、眺めるっていう意味でいいのかなと思うんですけど、その辺なんか感じることってあります？
そうですね。本当 CMU はめちゃくちゃいろんなコースがあって、そうするとパブリケーションのコースとかもあれば、なんかもっと全然デザインとか、ソーシャルサイエンスの話の授業とかもあって、で、やっぱりなんかテクニカルな研究者だと、テクニカルなことに興味があるんで、そんなしたなと取りたいなと思うんですけど、なんか学部のそのシステムとして、他からも取れよって言われてると、なんか調べますし、結果なんか選んだやつとかで、そこで得た視点っていうのが、結果的に自分のテクニカルなリサーチの幅を広げてくれるところは結構実感してるので、その辺のベネフィットはありますね。で、さっき原さんの話を聞いて、そのインターンとかって結構博士の間にできる、特権特権な気もしてて、5年あると結構先輩とかも2、3年は夏は出稼ぎに行く。やっぱアメリカだとでも本当にもうビッグテックとかに HCI のポジションがある。最近ちょっとリセッション来てますけど、あるので月本当1万ドル近くとか、夏の間生み出して、それをちょっと貯蓄していくみたいな人とかは多い気がしますね。そういう意味で日本で、加藤さんの参照だと思うんですけど、日本のそのインダストリーみたいなところで、HCI 研究者のポジションがどのくらいあるのかとかは、ちょっと気になりますね。
そうですね。なんか、多分中川さんが今、まさにインターンしてるオムのサイネック X とかは、なんだろうな、そういう国際情勢も、把握した上で、戦略的に多分、博士のインターン取ったりしてると思うんですけど、産総研の場合は、リサーチアシスタントっていう仕組みがあって、割とこれは昔ながらの大学の、RA とちょっと近い仕組みなんで、若干違うところはあるんですけど、そうですね。やっぱり、 なんかこういうのってカルチャーだと思っていて、アメリカの企業で強いところは、マイクロソフトリサーチとか、最近だとアップルも、すごいリサーチインターンいっぱい雇ってますけど、なんかそういうところが、ちゃんと高待遇で論文出せるよって言いながら、なんか雇うっていうのは、なんか、アピールになりますよね、学生にとってはね。一方でなんか多分、原さんと僕で一緒にいた時なら、アップルの、リサーチャーの人から話を聞いたと思うんですけど、なんか、インダストリーの場合ってやっぱり、インダストリーならではの制約がついて回るっていうところもあって、まあ、マイクロソフトリサーチがちょっと特殊だった面はあると思うんですよね。なんか結構、やった研究、パブリッシュどんどんしていいよって言ってて、なんかすごいオープンな、カルチャーがあそこにはあったんですけど、なんか他の会社さんだとやっぱり、やってたネタ、そのまま何でも外に出していいわけじゃなくて、やっぱりプロダクションに生かす前提でやるから、あるところまで到達したものは出してもいいけど、なんかそこまで到達してないものはそもそも表に出ないで、学生さんも実は、ポートフォリオに加えられなくて終わっちゃうっていうケースもあると思う。僕も実は3つ目のインターンとかそのケースだったんですよね。結構昔ですけど。だから、なんかそういう、なんだろうな、アカデミアとインダストリーの違いっていうのは、どの国にも多分ある、共通しているところはあるような気はしますね。アカデミア側から見ると、どうですか、原さんとか、学生さんにも結構インターン推奨してるって聞きますけど、その心は。
僕も、なんか、2回くらいインターンに PC の時に行ったんですけど、やっぱり、インダストリーってどんなもんなんていうのが、知りたかったんで、そうですね、それを知るチャンスがあるんやったら、ぜひぜひ行った方がいいかなっていう気がしますね。僕は結局、ずっと、大学にいるんですけど、学部、短大行って、で、PhD で、メリーランド行って、ポスドクして、で、今、シンガポールみたいな感じなんですけど、そうですね。なんか、できれば、インダストリーにはもうちょっと、インターンだけじゃなくて、もうちょっと、行って、いろいろそっちのことを勉強したかったなって気がありますね。やっぱりリサーチは好きなんで、最終的にはリサーチしたかったなっていうのは思うんですけど、そうですね、インダストリーのプラクティスとか、そういうのが知りたいとかあったんで、赤さんも言ってましたけど、ちょっとそれをつまみ食いみたいな感じで、インダストリーの雰囲気わかるんだったら、ぜひぜひ行った方がいいのかなって気がします。なんで勝手には、行け行けるなら行けって言って。
全くその辺は僕も同感ですね。で、あと、ビッグテックっていう意味で、やっぱりアメリカってそういう強い会社がある意味いくつもあるじゃないですか。だから、研究インターンという時に、割とアクセスがいいっていう面はあるのかなっていう気がしてて、つまり、インターン生の募集人数、あるいは採用人数も、多分地域別で見たときには、当然やっぱアメリカの大学院生の方がいっぱい雇われてる気がするんですけど、その辺って、なんか、感じることありますなんか。
僕から始めさせてもらうと、確かにアメリカはオポチュニティ多かったなって思って、日本僕ちょっと、日本で研究したことは実はあんまりないんで、学部の時だけだったんで、あんまよくわかんないんですけど、シンガポールは、確かにアメリカ系の企業のインターンのポジションは少ないんですけど、最近は中国の企業とか、なんだっけ、TikTok のあそことか、あと、リアルセンスじゃなくてなんだっけ、なんか AI 系の企業ですね、とかがあって、なんかそういう、あとファーウェイとかもあって、そういうところにインターン行く人もいますね。なんで、ちょっと毛色が違うかもしれないです。ただ、あそこら辺は、ペーパー出してるのか、ペーパー結構出してますね。なので、結構そこら辺一緒かもしれないです。企業によって違って、ペーパー出すところはペーパー出すし、本当にがっつり開発ばっかりしてるところは開発する。
なんか今名前が上がってたような企業って多分リサーチインターンの受け手側のリサーチャーたちも多分欧米の、それこそビッグテックのリサーチのカルチャーとかを知ってる人たちがそういう なんだろうな、陰性のインターン受け付けてるような気がしますね。
どうなんですかね。けど確かに MSR とかあったら、MSR ベイジンとかあったらそんな感じもするのかもしれないんですけど、どうなんですかね。結構最近は本当にアジアで勉強して、で、アジアの企業で、主に中華系ですね。主に中華系の企業で働いて、で、ポストそこ、欧米とかだったらインターンとか行ったけど、主にそのアジアで勉強してましたという人も結構いますね。
へえ、なんかそれちょっとニュージェネレーションな感じが。
ニュージェネレーション。
なんかそうです。僕の時は、それこそ MSR のアジア、ベイジンにリサーチインターン行ってたんですけど、当時はもう、とにかくアメリカに行く時の踏み台に MSR 使ってる子たちがいっぱいいたんですよ。で、なんかそのエネルギーに僕は結構圧倒されたことがあって、あとは、僕と同世代だと、結構なんだろうな、それこそ中国とか、アジア圏で、インダストリーで研究ラボを始めたとか、そこでリサーチサイエンティストやってるって人いるんですけど、その人たち、やっぱりアメリカでのインターン経験とか、アメリカでの PhD 経験、カナダでの PhD 経験を持ってる人たちが僕の知り合いだとほとんどだったんです。同世代だと。だから、その人たちは多分ちょっと今の話で言うとオールドジェネレーションで、でもそういう人たちが多分元の国とか地域に帰っていって、また、ちゃんとした HCI とかのプログラムを作ったりすると、その地域の中で純粋培養されるような優秀な学生さんっていうのが出てくるっていうのが、じゃあ最近の状況なのかもしれないですね。
ちょっと一点補足なんですけど、確かに HCI だとそんな感じかもしれないですね。なんかコンピューターサイエンス、一般だと結構、ローカルとかも多いんですけど、AI とか。ただ HCI やっぱりめっちゃ少ない。めっちゃ少ないというか、今加藤さんがおっしゃったみたいな感じかもしれない。
そうですね。あと、ちょっと大学の、話に戻るとですね、海外の大学と日本の大学って、大学院のその授業とか課題とかの多さが違うんじゃないかっていう、これ質問が来ていてですね、スケジュールがどんな風になってるかって、多分学生さんの中川さんと荒川さんから、どういうその詰まり具合なのか、もし日本と比較できればどういう違いがあるのかって、印象いかがですか？中川さんから聞いて大丈夫ですか？
そうですね。日本の大学は、友達の話しか知らないので、ちゃんと比べられるわけではないんですけど、まず前提としてイギリスの学部が3年なので、教養がない以外に、高校である程度、しっかり、スペシャル、専門的なことを学んでいるから、3年で済むよね、みたいな感じで、結構スタートが大学1年生後期とか、日本でいう2年生のところから始まってしまうっていうのがあって、なんで、留学生は結構、ってなるところがあって、結構そこでまず、他の人よりも、ローカルの人よりもちょっと課題が大変に感じるところはあるのと、あとイギリスの大学ってコースワークやテストで 100% 決まるとか、結構一発勝負なところがあるので、結構すごいストレスが来て、で、スケジュール的には日本の情報化とかすごい大変なところと一緒かもしれないんですけど、そのストレスが強いので、過去には教授に質問しながら過呼吸で倒れたり、でも過呼吸で倒れても質問し続けるから、留学生は気持ちがわかるので、みんなちょっと座りいいなみたいな感じだったんですけど、もうローカルの人たちからしたらもう、なんで来たの学校にみたいなとか、もう普通に救急病棟に今日行ったとかストーリーに上がってたり、結構スケジュール的には一緒なのかもしれないんですけど、メンタル的には結構きますね。あと天気ですね、きっと。天気のせいできますね。
リビアですね。めちゃくちゃ。そう聞くと。よくぞ生き抜いてらっしゃるなと思って聞いてましたけど。そうなんですね。CMU はいかがですか？博士入ってから。
そうですね。まず、学部生とか見てると、僕東大のアンダーグラッドだったんですけど、多分、同じぐらい、CM の忙しそう詰まってるかなみたいな感じがします。やっぱ課題の量が多いっていうのはその通りかなと思って、 それが毎週のようにたくさんバーバーって出てきて、出さなきゃいけないとかがあるので、結構その全部やろうとすると難しいから戦略的になんかみんなやっている。これはまあ落としていいやとかで、うまく戦略を組みながらやってる気がしますね。で、博士は多分、本当にそれぞれ人それぞれで、その人とアドバイザーのスタイルとかそれぞれで変わってくるのかなと思います。なんかアドバイザーがすごいハンズオン、めちゃくちゃ、なんでアドバイスしてくれるような人とかだと、多分、みっちりやるっていうのが、本にとってもいいですし、アドバイザーもそれを要求するっていうのがある。ますね。僕のアドバイザーは比較的、ハンズオフで、まあ、割と緩めてあって、僕はもう自由にスケジュールを組めているので、本当気分によって今日休もうとかは全然できるので、これ多分 PhD って長い生活の中でうまく、なんか心身面をコントロール、マネジメントするのかなと思います。
でも荒川さん、今のアドバイザーとはどういう出会いだったんですか？
今のアドバイザーは、もともと PhD に出願するときに興味はあったので、連絡はしてて、で、受かった後に、CMA オープンハウスっていうのかな、オープンハウスがあって、そこで、なんかポテンシャルアドバイザーとワンオンワンをするみたいなのがあって、バーチャルだったんですけど、で、そこで、なんかいいなと思って、特になんか社会問題をセンシング、マシンラーニングで解決するってところが、プロジェクトとしてやりたいなと思ったので、ほぼほぼもう行く前に決めてて。で、9月に、8月で渡米したんですけど、5月の前の3ヶ月間ぐらい一緒にプロジェクトやったりとかして、なんか事前のなんかマッチングみたいなことをお互いも測って、9月行って、よっしゃ、じゃあよろしくみたいな感じになったって感じです。
そうか、そのタイミング、指導教官が決まるタイミングっていうのは、まあ、とりあえず行けることが分かって、その後、決まってくるっていう感じなんです。
これちょっと CMU のなんかユニークかつ、僕は割とポジティブじゃないなと思ってるところで、なんか入学のオファーを承諾する時点では誰がアドバイザーになるか分かんないんですよね。
なるほど。
で、9月に入って、3週間ぐらいマッチング期間があって、そこで決めなくちゃいけない。そこで、まあ、5年間分の、人生を捧げる相手を見つけるっていうのはなかなかまあハードで、しかもあんまりストラクチャーされてなくて、学生がそれぞれ、なんか、自分で探しに行って話してみたいな。で時によっても教授が今年ちょっとファンディング的に取らないんだとかいう人もいたりするので、なんか、僕は比較的満足のいくマッチングになったんですけど、そうじゃない子も当時はもちろんいて、で、なかなかそこでリサーチうまく始められなくて、結局後でアドバイスが変えるみたいな例とかもあるので、なんかそこはちょっと HII の、あんまり良くないなと個人的に思ってる。
なるほど。確かに不確定要素がちょっと大きいですね、そう聞くと。
なんか、彼らの戦略的、言い分的には、まあなんか、すごい幅広いことやってて、どの先生もすごい専門性があるから、しっかり探索した上で決めろって言うんですけど、っていうのがありますね。
しっかりと5つ3週間ってことですよね。まあ、候補を事前に決めておくにせよ。そうなんですね。まあ、日本だとね、割と、まあ、指導教官の希望を決めておいた上で、先生と相談してからそもそも受験するっていうケースが多いような気がするかな、博士課程は。原さんとかどうなんですか？なんか、もう原さんと研究したいっていう学生さんが来るって感じ。
そんな人はあんまりいない。どうなんですかね。そもそも、PhD をやりたいっていう人が、さっきも言ったように少ないんで、ローカルからあんまり上がってこないんですね。ローカルのアンダーグラッドの子とかは大体就職しちゃう感じなんで。なんで、PhD の子はメインは、中国とか、インドとか、インドネシアとか、その周辺の東南アジアの人が多くって、まあ、時々違うところの人もいるんですけど、やっぱり、近隣の、近くの、国から来る人が多いですね。で、これもまたさっきちょっと、ふわっと言ったんですけど、やっぱり、HCI をやってるっていうところが、結構アメリカとかイギリスに比べたら、やっぱり少ないじゃないですか。少ないですよね、アジアだと。日本とか韓国とかだったら結構、コミュニティが出来上がってる感はあるんですけど、シンガポールでも、まあ、僕が来た時とか全然人がいなくて、あと僕の他に2、3人いるみたいな感じだったんですけど、 最近はだいぶ人が集まってきてるんで、だいぶ良くなってるんですけど、それでも、この HCI 自体のプレゼンスが少ないんで、なんかアンダーグラッドで勉強してるコンピューターサイエンスの人が、HCI ってなんだよみたいな感じなんで、そもそも、そもそも、なんというか、スコープに入ってない、あんまり入ってないんですよね。なんで、あんまり、こう、そうですね、ちょっとハイアリングは難しいかなっていう感じですけど、こっちから見たらハイアリングが難しいし、学生から見たら、なんか HCI をしようってモチベーションがそこまで湧かないのかなっていう感じですね。
ありがとうございます。そういう意味で言うと、その中川さんが高校の時に HCI を知ってるっていうのは僕にとっては衝撃的だったんですけど、でも世代の違いを感じるとともに、その HCI と、まあだからある意味日本だからその知れたっていう面はあるんですかね。中川さん、なんかその辺って。
そうですね、あんまり、あんまり人にこれがヒューマンコンピューターインタラクションだよっていうよりは、このやってるインタビューって学問的にあるのかな、ユーザーインタビューって何ってどんどん調べてって、たどり着いて、水戸ジュニアをオーガナイズしてる方も HCI 関連なので、なんか多分それでキーワードが入ってきて、HCI を知ったみたいなことだと思いますね。
なるほど。やっぱりそういう人的なネットワークって結構大事だなっていうのは話を聞いてても思いますね。やっぱりなんかそういう、もちろん検索とかで出てくる情報ももちろん大事なんですけど、研究者の研究のネットワークってやっぱ結構いろいろな影響があって、実はこのパネルで触れてほしいトピックにも最後に今ちょっと出てきたんで、最後のトピックにしようと思ってこのコネクションですね。日本の研究者より海外の研究者の方がコネクションがなんか強い印象がありますとか、なんかそういうメリットとか、国際差みたいなものって皆さんの経験に照らしてどう思われますか？
いや、絶対あると思いますね。まあ、インターンに関してだと思うんですけど、やっぱりアメリカに、まあ、CMU だと僕の CMU だと、まあ、OB とか OG、アラムナイの人たちが、今企業とかリサーチやられてたりとかするので、なんか、割とその正規の選考プロセスに出す人は多くないイメージがあります。学会会場とかであって、なんか夏探してんだよね、みたいに言って、でちょっと一回話すかと言って30分話してオファー決定みたいな。なんか、そういうのが結構あるな、みたいな気はしますね。
原さん、いかがですか？
いや、僕もそう思いますね。てか、むしろ、それがメインというか、多分、研究やるんだったら、それとパブリケーションしか誰も見ないみたいな感じなんで、なんか別に、そんな、テクニカルに強いとかも、ちょっとなんていうか、セカンダリーなファクターなんですよ。やっぱりパブリケーションを出してるっていうのは、やっぱり研究者だったら評価。PhD の学生とか、そうですね。PhD の学生とかだったらパブリケーション出してるっていうのが評価されて、あと、ネットワークは、やっぱり、すべてに聞いてくるというか、自分のパブリケーション、まあ、自分のやった研究っていうのをディセミネート、みんなに知ってっていう、そうですね、コミュニケーションする上でも大切ですし、荒川さんが言ったみたいに、就職でも大事ですし、で、ハイアリングとか、ハイアリングなり、自分がハイヤーされるなり、自分がハイアリングしたいなり、いろんなシチュエーションあるんですけど、そこでも聞いてきますし、すべてにおいて聞いてくるんで、あと、僕とか、ファカルティになったらグラントとかでも、コラボレーターが外部の人必要なんで、そこら辺でも聞いてくるし、すべてにおいて聞いてくるんで、むしろそことパブリケーション以外何が評価されるのかっていう感じです。
すごい切れ味の鋭いコメントありがとうございます。中川さん、今の話聞いて、こう思うところあります？すいません、なんかちょっと、雑な振りになってしまったんですが。
なんか、まだそんなに体感できていないっていうのは前提としてあるんですけども、コロナ禍があって。で、ヨーロッパはやっぱり隣の国が近いので、結構そういった意味でもネットワークが広いのかなと思うんですけども、私はなんか最初の取っかかりに苦労して、多分一回入ってしまえばつながるんですけど、 コロナ禍で先生来たことないし、メールしても全然みんなメールするので埋まってるしで、もうちょっと手前はワンやしていて、で、入れないけどコネがないとインターンもさせてもらえないし、ビザも問題的に研究室にも入れてもらえないみたいな状況が続く中で、ある意味なんか日本の方はこうちゃんとアプライしたら見てくれたり、そういったところでは結構フェアだなと思いますが、日本だと一部こう海外大なのでって取られることもあるので、ちょっといろいろ苦労するところではあります。
ありがとうございます。なんかそういう意味で言うと、意外と日本は穴場かもしれないですね。そのフェアに見るっていうか、それこそやっぱり有名なところだとレジュメとかね、山のように来ますんで、見てる時間ないだろうから、そういう意味でも、そのコネクションが大事になってくるっていうところもあって、ただ、やっぱり話聞いてると、そのコネクションが大事っていうところは、多分大前提で、それが強いか弱いかっていうのは、実は多分そのキャリアのどこかでコネクションができると、意外とそれは続いていくものだなっていうのは思うんですよ。なんか人的なネットワークって、やっぱり、そう簡単に切れないというか、僕が以前博士の頃に、五十嵐先生って指導教官から言われて、今でも印象に残ってるのは、なんか、インターン行った時の、同じその時のインターン生とかって、ある意味、ずっとそのレベルのキャリアでこう上に持ち上がっていくんですよ。もちろんインダストリーに行ったり、違う、研究職じゃないところに行ったりする人もいるけど、だんだん偉くなるんですね、知り合いが。で、そういうコネクションが続いてれば、どっかで要するに、ある意味そのネットワークへの参加権が、チケットが、あって、それをどこかで、手に入れていれば、その後、は、意外とそんなに違いはないというか、特に HCI って、みんな割とエシカルな側面を気にするじゃないですか。だから、いろんな国際会議の委員とか選ぶときも、なんだろうな、リージョンのバランス取るんですよね。アメリカ大陸から取りすぎると良くないから、ちょっとアジア圏からもとかっていうと、なんか僕とか原さんとか、アジア圏なんで、なんかそういう意味でピックされることもあるし、なんだろうな。だからやっぱり、コネクションが強いっていうのは、環境が強いっていうのはもちろんアメリカとかカナダとかあると思います。一方で、実はコネクションそのものに関して言うとかなり個人レベルというか、個々の人それぞれになんかそういうコネクションの強くなるタイミングっていうのがあって、なんかそれ以降は実は結構キープしてるっていうのが僕の個人的な印象ですかね。なので、ちょっとこれ結構日本の学生さんが聞いてるかと思うので、どこかのタイミングで、参加すればいいっていうものではあるかもしれなくて、そういう意味ではさっき原さんが言ってたパブリケーションですよね。日本の教育システムのいいところって、卒業論文とかから結構パブリッシュする人はするので、なんか、早い頃から、研究論文書けるシステムになってるのは、そういう意味では強いかもしれないですね。はい。すみません、ちょっと喋りすぎてしまったんですが、実は時間が、過ぎておりましてですね、なんかそんな感じで、ちょっと国際的にご活躍する皆さんのお話も聞きつつ、日本の皆さんに、なんか、もし日本の皆さんに言いたいことがあれば一言ずついかがでしょうか。中川さんからどうですか。
私からですか。他の二人を様子見て考えます。
そうですか。じゃあ原先生でもいいですけど。
いや、特にないです。特にないです。
それは
だけど、
リクルートしたらいいんですか、原さんも。
そう
今
ですね。
まさに。
いや、シンガポール来たければ、もう絶賛受け入れてるので、来てください。
はい、なんかイギリスの友達も CS の友達も結構シンガポールに交換留学行ったりしていて、
そうなんですか。
なって思ってたので、ぜひまた
遊びに来てください。
はい。
いいですね。荒川さんも何か。
HCI で、いろんな先生がいて、僕の先生も含めて結構、学部生とか修士生のインターン生とか、募集が積極的にやってるところもあるので、なんか全然、興味ある先生とかいて、なんか、話してみたいとか、この人の研究興味あるとかあったら、全然気軽に連絡ください。なんかそういうポジションとかもしかしたら機会が、全然あったら共有したいなと思うので、待ってます。
ありがとうございます。 そうしましたら、すいません、お時間も実は過ぎてしまっておりますので、このあたりでと思うのですが、皆さん本当にお忙しい中、お時間ありがとうございました。今最後に荒川さんのコメントにありましたけど、気になったら連絡を取ってみると良いと思いました。というわけで、はい、これからも研究頑張っていきましょうということで。はい、本日はありがとうございました。このあたりでお開きとさせていただければと思います。ありがとうございました。
ありがとうございました。
ありがとうございました。